Hello everyone, I am Senthil Kumar, working as Assistant Professor in Sri Ishwar College of Engineering. This is a third video, and in this video I am going to discuss about a network software. In the previous videos, in the first and second videos, I discussed more about a network architecture and protocol specifications. So a good network architecture and protocol specification is not alone for a success of network. So we require a very good application. So based on the application, our network is going to used by the end user. Most of the people knows about the network or knows about the internet only through application. Every day, most of the people are using web browsers, email client and more networked application. So knowing more about networking application is also an important part in studying the computer network subject. So in this short video, I am going to give you an introduction about creating network applications in Windows operating system. You can perform the same operations in any other operating system. It is not operating system dependent. Okay, so let's see how to create a network application. We are going to create a network application using application programming interface, that is sockets. Practically, it is not possible to directly access the underlying networking hardware. So we are going to access or we are going to start programming from an endpoint called sockets. So socket is an interface that is exported by the network. Today, most of the protocols are implemented in software. So we can say this as the interface that is provided by the operating system for us to design the network. So this interface is called as the API or sockets. So the socket interface was originally provided by the Berkeley distribution of Unix. Now this is almost supported in all operating systems. So each and every protocol provides a certain set of services, and with the help of API we are going to access those services. So our API provides a syntax by which we can access those services. So it is very simple. Each and every protocol in each and every layer going to provide a certain set of service to everyone. So with the help of API, we are going to access those service, and the syntax is provided by the sockets. Now what is a socket? So this is a point where a local application process attaches to the network. So you are going to create an application, and from this particular place you are going to attach to the network. So this is an interface between an application and the underlying network. So the application creates the socket and uses the services provided by the network. So the interface defines the following operation. One is creating a socket, then another one is attaching a socket to the network, then sending and receiving the messages through the socket, then closing the socket. So these are all the four operations you are going to perform in order to create a networking application like web browsers. So these are all the few parameters that you are going to use in creating a socket. So in order to create a socket, you are going to use this function socket. So the socket function accepts three parameters. One is the family, another one is a type, then the final is a protocol. So if you execute this function, then the socket number will be written, and that is called as a socket descriptor. If the socket descriptor returns -1, then it indicates an error, and if it returns some positive number, then it indicates a success. So if positive number is written, then it means the socket is created successfully. Now let's see more about the parameters. So this is a socket family parameter. In this parameter, the first parameter pf-inet denotes the internet family of IPv4, and this pf-unix denotes the Unix pipe facility, and this pf-packet denotes direct access to the network interface. Then we have a second parameter, that is socket type. Here we have two parameters. One is sock stream and another one is sock DG RAM. So if we are sock stream, then it means we are going to use TCP protocol in transport layer. If you are going to use sock DG RAM, then it means we are going to use an UDP protocol in transport layer. A combination of PFINet and sock stream denotes that you are going to create an internet application that uses a TCP as a transport medium. So these are all the examples of creating a socket. So after creating the socket, the next step is binding an IP address to the created sockets. So before discussing more about sockets, let me explain about a telephone system analogy. So how telephone system works. In order to create a telephone system, you require two telephone devices in both the end. So your telephone is called as an endpoint. Then after creating the telephone or after placing the telephone, you need to assign a unique telephone number to both the end. So here we are going to implement this process by using a function called bind. Then after that, after assigning a unique telephone number, then one person should turn on the ringer and wait for the call. So we are going to implement the same using a listen function. Then another person in the another end should pick the dialer and simply types the telephone number of opposite person. So here we are going to implement the same operation using a connect function in socket. Then in the another end, the person should pick the phone. So we are going to implement the process of picking the phone using accept function. Then after that, both the parties are going to speak with each other. So we are going to transfer the messages using send and receive function. Finally, hanging the phone after communication is over. So we are going to implement that using a close function. So these are all the operation involves in creating a socket. So the first step is creating the endpoint, that is creating the socket, that is equal to placing the telephone line. So we are going to place the telephone in our network programming. We are going to create the endpoint using the function socket, and these are all the three parameters used in the socket function. The second step, if it is a server, then we have to first bind the IP address to our server. So this is the first step, int bind. In int bind we have three parameters. One is the socket. Here the socket is nothing but the socket descriptor that is returned by the socket function. So you are going to bind the address. So bind the address, that means you are going to assign the IP address to this newly created socket. And your second parameter is struct sock addr star of address. So in this particular place you are going to use an IP address of a server machine. Then here we have int addr hyphen length. So this is a length of the address you are going to assign to this newly created socket. Then we have another function listen. Here we have two parameters. The first parameter is init socket, that is a socket descriptor. Socket descriptor is nothing but the socket descriptor is actually returned by the socket function in the beginning. Then we have init backlog. So this init backlog is nothing but the maximum number of pending connection that can be allowed in a queue. So it means your server is able to accept some 5 to 10 connections based on this backlog value. So if you are giving a 10 in this particular place, then your server is capable of handling 10 clients simultaneously. Then we have accept statement. Accept statement accepts the connection from client, and in this place this IP address is the IP address of the client, and this is the length of the IP address of the client. So the bind, bind is mainly used to specify some address. So in this case the network address of the local participants, that is the server address. And here we have listen, that defines how many connections can be pending on the specified socket. Then we have accept that carries out the passive open in server. Then in the client end, we are going to use the connect function to connect to the server. So here this int socket is the socket descriptor of the client, and the struct sock address star of address is the address of the client. Sorry, address of the server. So the address of the server you are going to connect. So the client address will be automatically fetched by the system. So here this address contains a remote machine address. In general, in a regular practice, the client usually specifies only the remote participant's address and let the system automatically fill in the local information. From the server side, a server usually listens for messages on a well-known port. So the port is already defined in server. The client actually does not care about which port it uses for itself. The OS simply selects an unused one in the client end. So once the connection is established, the send and receive function is used to transfer the messages between the both parties, the client as well as servers. So here the parameters are almost same. So let me conclude this session by giving all those introductions. Let's discuss about performance in the next video.